Hi, we're Team 49. We're presenting our project, the Lumen Locator for MakeOHI 2023. This is our team. So this is our vision.
So we had three main components to this. We have the data acquisition, and we use that data to calculate wattage that we can then use to inform our decisions for our software and hardware systems.
For our data acquisition system, we utilized a solar panel with a breadboard and some resistors to scale down our voltage using a voltage divider for the Arduino. And our methodology involved reading reflected light levels from several materials, collecting and denoising several thousand voltage readouts. We assign scores to materials based on performance. For our hardware, we used a mini solar farm, which involved 3 solar panels and attached to a servo. This servo moved based on the angles that we provided. And the angles were provided by making some trigonometric calculations to determine at what angle the sunlight hits. And then based off that, providing the ideal angle for the solar panel. And this is some linear algebra we use to account for the Earth's tilt. And this is our hardware demo. In here, you can see that the solar panels move down based on the daytime and move back up to account for the angle at which the sun hits.
So our goal with our software was to give a recommendation for where to put a solar panel. So our first step was to do some image processing to make all of our data accessible to humans. And part of that data processing was a computer vision model. So we used k-means clustering to group like regions. And then based on that and the data we've previously acquired, we use a K&N model to give that material a reflectivity score. And then at the end, we merge these two models to give a overall picture of where to place a solar panel. And we have a demo of that software here where we're using a light to simulate the sun. And you can see in the red is your current light, and the green is all the past light for the entirety of the live feed. And you can see it tracks the sun as it moves, and you can even see that you can see shadows from objects. And so we had reflectivity scores that we made based off of our data, and we figured this is a good way to save costs because you don't need a large team to survey land. You can just put this camera out there.
And so our roadmap going forward, we'd like to include wireless communications to multiple panels. We'd also like an external camera so that we can adjust the solar panels based on that data and test a wider range of materials so that our Lumen Locator can use them. Thank you for your time. We really appreciate this, especially given the fact that you guys encouraged us and gave us the opportunity to use computer vision and to make it.